Hey, just for fun, let's take a look at my stickers. Now, I forget that I actually have them stuck on the back side of my plasma cutter here. And look at that, even way back in 2017. All right, that was great days, huh? And then all the way around to this side here. Let me get back here a little ways there. So that was actually my first start of my sticker collection, and a lot of them were actually after I made my first trip to the first Barzy Summer Bash. All right, now let's venture into the next collection of stickers. The X-Carve, when I made up the X-Carve and I was setting it up, I took all my extra stickers. In fact, actually, I think I even have, okay, this is the board that comes into here. I call this my sticker corral. Okay, because the stickers actually went all the way around my corral here, and sharing everybody that's on the YouTube community there. All right, and then I had these here working along the edge there. I threw in a couple other stickers, and then lately I have a few gun stickers there as well. But this was another collection there. And that was when Adam Booth got his new stickers there. All right, I just added, Keith gave me a couple extra when him and Clark came and visited me. And so that's what I got in this area here. Now let's go over to my sticker door. Clark from Windy Hill Foundry came and gave me his sticker. He ran over the door, stick it on there, and then Keith put his over here. So the other two floating stickers that Keith left me, I put them over there at the ice car. But I originally had one out there on my plasma cam from the very beginning. All right, I just wanted to cover everybody that I have so far, and I appreciate it. It actually, it wasn't until the other day when I had a couple more stickers added to the door here that I really was taking a look at my collection that I do have. Love everybody for the stickers. Thank you very much. Ladies and gentlemen, welcome to Job Shop USA. My name is Keith, and we're here in my shop once again. See this? We're going to be starting to shoot videos in between Pearl and my closing and the Bridgeport. And this is my readout. The reason why I call it a readout instead of a display is because it's way out here in the middle of my aisle. Look at, I'm holding my two handles there. This is where I go in and out. Also too, you know that area under the pedestal on your Bridgeport? You know how you like to, or you know how you don't like to bend down and wipe it off because it bugs you? Well, after you bend down, wipe it off, and then come up and hit your head here, that's a twofer. Okay, before we go any farther on this video, I'm going to snip all of these ties right here. I'm going to unbolt this thing here. We're going to set it off to the side. We're going to take 4 inches off of this end. We're going to take 4 inches off of that end, drill 2 holes, put the caps back in. We're going to bolt this thing in, and center of this is going to be right over here. All right, a couple minutes, Look at that. Look how much room's in here. Bam, bam. You can almost run through here. Running in the shop is not a good idea. All right, let's get on to our program here. We're making or making a new piece to replace the brake cup. And this is the brake cup. This goes into the housing right here. The input shaft feeds through here. And then this is the brake shoe, which actually mounts onto this hub, which pulls it and engages the brake, or pulls it this way and engages the clutch on the outside of the gearbox. So these pieces kind of all go together. And if you remember when we pulled these apart, this was a brake and clutch video on Pearl. And right now I have this part in here backwards. I'm getting ready to rough out this taper right here, or this angle on this. And then we'll go for a relief down into this root right here. And then we'll finish this diameter up here and finish the bore. And the bore is just clearance, but we want it to be true with the rest of our part here. And then we'll be able to part off this chunk, and then we'll be able to flip our part around, and we're going to mount it in there and be able to do the taper that we desire to have without the little grooves, and making sure that we have plenty of material. I think this cone has been reworked before, because it has been removed and reassembled, and it wasn't assembled properly. Okay, and that should be the bore. See that relief against that face and that diameter right there? That's so when it goes into the bore is sharp edged inside the housing. And that's so that you make sure that you have clearance there, so that you're against this face and right in that diameter right there in the bore. We're going to use our D&MP to reach in there and give it enough. I believe we can give it enough to have clearance in there. Okay, there's 0 each way. Looks like we got enough in there. Now this face, we didn't face this face yet, so we got to take a look at that. Okay. Well, that looks a lot better now, don't it? We finished up the OD of this part, and all we got to do is part it off. And we're going to do that. But in the meantime, we are working on something new. We drew up our 3 seals, and this is a new printer format with a new material. This is using silicone 40A. Now this is what we have been practicing and making and testing the material with the TPU. With the new silicone 40 materials, we get to make a material that can be for seals, gaskets, connectors, industrial, and automotive applications requiring high thermal and chemical resistance. So we have some in the tray here now that are in drying, waiting for the next procedure. Now the process is, you go ahead and well, it's not gonna let me switch screens, but right now we're printing another section in here. There we go. So it'll be about 7 hours and 18 minutes for these to print. And when they come out from print, we're putting them inside a chemical bath here of isopropyl alcohol and butyl acetate, a mixture specifically for this material. Then we dry them for an hour, and after they're dried for an hour, then we're going to put them in our ball beaker. We needed a beaker, but the ball jar works just the same thing. And then we'll be putting them inside there, and they actually get heated up to 60 Celsius in the jar of liquid water, 45 minutes. And then we actually will have rubber silicone seals. We polish this surface up here so we get the diameter to match. We're half a thousandth to maybe 4/10, 3/4 over this diameter here. Now you notice this is like 3/4 of an inch, and this is like 850. I made this 100 thousandths longer. We have more room in there. I want this to be firmer in that bore. If I can get away with it, I want more material. See where that set screw comes down in with the dog point? How close that is to that edge right there? Okay, I want it to be inbound a little bit more. All right, we're going to set up our parting tool, and we're going to part this off. We're done with the outside here. All right. All right. It's all right. Okay, so we just got a little bit of bore to do, and then it gets installed. And then we're going to put that dog point in place once we probably freeze and install this cup. Okay, I want to kind of check the fit of this, but because you guys haven't really seen it yet and I haven't pulled it out of here, I got my little indicator in here. And now if I rotate this slightly, the needle will jump about a half a thousandths. But as far as straight in and out push, I can't get it to move. But if I take my pry bar and I put it in here against the gear and against the wall here, and then I can push it that way and get the quarter thousandths, and then I can put it in this way here, and then I can get about a thousandths that way. It feels good on the rotation, and the gears spin. I'm engaged on this one here, okay, and we got good feel on this, and the whole thing, there we go, has somewhat, it won't free spin, you know. I mean, I can get a revolution maybe out of it on a spin. I'm pretty happy with it. I actually had a different shim pack in here, and I had 2000s on the preload, and I could get probably a quarter of a rotation on the gears by just putting, you know, flinging them like this, not getting a whole revolution like I am. A little research online so I could find a little bit of information that kind of explained it, and this little graph right here actually kind of explains it the best that I've seen, that makes it simple. Here's basically the hours of life, and then this is in play and preload, and then your climb or your peak. Zero is this line right here. Now you see the better of the life on the other side here, just past zero, meaning maybe a couple tenths. Each one of these lines here was, this would be 8,000, so that would be 4,000ths, and then this would probably be like a thou and a half to a thou and 7/10ths, either way on these two little lines right here. So you take that one out there, so anywhere between probably a thousandths clearance and a thou and a half preload is the optimum range. Now the key is, this is when you're at operating temperature. This is where you want to be. Now, temperature is created by resistance or friction. The gears on these shafts, this is the second line, and the two gears on the main shaft will come down in contact with this. This is the next shaft I'm playing with, and I don't have it clean yet, okay? This is the input. This is the one where it comes in from the pulley all the way at this end here, and then this right here is the clutch and brake side of this gear. So anyway, this gear will match with that one, and this one here will match with that one right there. This is the first set of contact, and this is I'd say the creation of the most heat in the gearbox is going to be generated and start off of these two gears, and then it's going to roll through the rest of the gears in the lathe. All right, so with this being the warm spot of it, I am happy with what I actually have set up here. All right, because I can't get it to give me anything unless I put the pry bar on it, and I don't really know how much I might be actually. I mean, this web is pretty solid, and I don't know where I'm actually coming up with the amount of travel when I pry it, but I'm putting the load on the bearing, the cup, the cone, and the race, and all of that. And evidently, when you don't have any force on it with the pry bar, you actually have no in play going either direction. I can, like I said, I can get it to move, and that's just basically side push like this on your indicator. We all know you get that. So I think I'm happy, and this is my decision to go ahead and let this shaft run like this. And actually, I love it. If you gauge that, and you can get this gear here to free spin, and there's no play there, and then when you shift it back the other way here, and you get that engaged there, you get this one here to. This is really sound. I'm really happy with it. Now we're going to start playing with this shaft, that clutch, and the brake. All right, and I'm going to probably get out that next center shaft and start looking at getting it cleaned up and start taking a look at it. This one here, now that we have that part of the brake parted off, I can go ahead and clean up the lathe, and then I can start putting, this needs to be in the lathe. I need to polish it up. I need to actually degrease it a little bit. This is the spacer that goes in between that cup or cone bearing right there. And this side here has a running rod that's actually connected with the slide of the clutch. And then this has got a bushing in here for the 1/2 inch rod or 5/8 rod to slide through on that end that's threaded for the clutch. All right, we're going to take a look at our seals. We changed our drawing around, gave them a little bit of a raft, and we got them in the vertical position so that we can get one complete side and the bore not to have any contacts with support. They leave a little tiny blim, but not bad. But they are flexible. Our group that we were printing is all done and rinsed there, and this is step 3 here. And this was submerge them in your beaker. We use a ball beaker, and these are some that I did the other day, but we didn't rinse them with their complete materials. All right, look at that. If you look at the texture on there, that's from the supports, but the side that has no supports on it's a nice, good, clean surface. Now these we'll bring out and we'll dry. And then we'll have to take the, that water's pretty warm. Oh, that feels a lot better when you follow the procedures right out of the printer, right into the right bath, and then into that process there. These came out good, but this is much better here. And I got to get something to reach down in there and grab that one. And these got about another 30 minutes to dry before I put them into the water and go through the curing process. These are all 2 different manufacturers of blue TPU, and this is another TPU made by one of the same companies here. We still have these as our backup. I want to show you a couple different things that I've come across, and we're still doing the chemical test. We're going to actually put one of the silicone rubber seals into the hydraulic oil that we use in the gearbox, and we're going to go grab the container of it now. We'll pull out the TPU that's in there now, and our other fluids and everything else still show us the same results as we did check on them last year. I wanted to show you the latest out of our machine and through the process, and this is the best looking silicone rubber that I've produced so far in the last couple of days. I've just started getting fully set up and got all the right chemical combinations and the timing and the temperature down 100%. Now the next thing that I'm doing, and you just saw that run through in there. I'm actually setting these things so that they're positioning up with a slight bit of wrap so that I can minimize the contact, so that minimize the little blems on it and get the better finish. If you actually look at that finish on there, that's some good looking rubber. All right, so we're gonna lay our rubber down. Let's get sealless. Serious about our seals. All right, one of the things that I ran into with the TPU was shrinkage. Okay, so it did make the bore tighter and it gave us more clearance in here. Now I measured all of them and it calculated the difference, and I actually modified my drawing. I just haven't gone through and actually printed some in the updated size dimension to compensate for the shrinkage. And that was, it didn't matter which one, even this small one here that goes inside here. And I did find my spanner wrenches again for what we made on this nut and the 7/8 nut that's here. There we go. Okay, and then this one goes in here. All right, and that one goes there. This is the seal that's going to go in there. And even though I'm going to pick the best side that actually faces the inboard side of the seal, and fits right in there. And then I'll get my wrench and I'm going to make sure that this will go and flush out where it's supposed to, because we got that inner arm and the outer arm here that's going to make contact. We probably should have lubed them up before we put them in there. It'd probably make them flow in there a little easier. And I'll get my wrench for that one there. And we're going to be creating, we got to create a wrench for that one yet. I don't think I have that small wrench yet. All right, now let's go to our fluids. All right, this is the hydraulic fluid here. And I guess I can use this. We put one of our small TPU seals in there, and still nice and pliable, no separation. It looks as good as when we put it in there. So I'm going to go ahead and I'm going to put this down in there, and we're going to leave that in there for a couple days, and we're going to see how our gear case oil or hydraulic oil is going to fare on that. This was water, no effect. Might as well get it close enough so you can see it. No effect on that. That was the water. This is the brake fluid. No effect on that. The acetone, we knew that it made it separate, and you can see the separation in there. All right. The acetone dried up. And this is diesel fuel. And diesel was good. No effect on it. The chunk we put in there looks as good as the day we put it in there. So we passed our chemical test there on the TPU. So this is our backup. We know that this will work, and we're going to print the proper sizes, because now that we have everything completely rebuilt and we're actually assembling our handles out here again, we'll be able to take off our handles like you're supposed to take off your handles to access your packing glands. Because remember, this was wick packing that you used to be able to change, which probably what I pulled out was the original wicking that was in there. Who knows how often they would have changed it. It definitely looked like it was 1941. Super excited about being able to print silicone and create extension boots, bumpers, O-rings, gaskets, and seals just like this. Pretty amazing what the new technology is letting me do with my old school talents. We're going to call it a night here. We're in overtime, right? No tax on overtime. Hey, wanted to let you know before I go, because we're done working with Pearl tonight. My next video, I'm going to go ahead and create it tomorrow. We're going to be back on what's in your job shop. And we have a new donated machine, and we had a full set of collets come in, and I'll talk about it there tomorrow. All right? You get her done. Thanks for visiting Job Shop USA.